Ladies and gentlemen, boys and girls, welcome to the Unit 3 Quiz 2 review on congruent triangle proofs. I'm going to be doing problems 3 and 4 in this video, so let's get right to it. Problem 3 says we're given that AB is congruent to AC, so we always mark our given information in the diagram, and that AD bisects BC. So AD, this segment, let me draw it in red so you can actually see it. This segment bisects BC, this segment. Now, when I bisect something, say I have a cookie, and I bisect it, I cut it in half. The two halves are equal or congruent. So when I bisect a line segment, each half is going to be equal or congruent. So I have some good information to start with, and I'm going to kind of plan this proof out verbally before I jump into it. I want to show that angle B is congruent to angle C. So ideally, if I could show that these two smaller triangles are congruent, then I could say that by CPCTC. So far I have two pairs of sides, sorry, and it's really jumping out to me that AD is a shared side and it's congruent to itself by the reflexive property. So it looks like I could say the triangles are congruent by side, 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 and then use CPCTC to prove that these parts of those triangles are congruent. So let's do that in paragraph form. So again, start with the given. We know from the given that AB is congruent to AC and AD bisects BC. So I said since AD bisects BC, we can conclude that BD is congruent to DC. And those are the segments that I double marked in green up there in the diagram. Then we said also AD, the side that they share, is congruent to itself by the reflexive property. Boogie, woogie, woogie. So we know that triangle BDA is congruent to triangle CDA, and that is by side, side, side. Finally, angle B is congruent to angle C by corresponding parts of congruent triangles are congruent. CPCTC. And I'll teach you guys this because you're cool enough to watch these videos, so you're cool enough to know this fact. In Latin, when people, or back in the day when they did proofs, at the end of the proof they would write QED, which in Latin means it has been shown or it has been proven. So you can put QED with a smiley face at the end of your proofs if you want to have math swag. Kudos to the other Mr. Gordon, my dad, who taught me about that. All right, finally we have problem 4. Um, and this time we have overlapping triangles. So it's a great idea whenever you have overlapping triangles to separate them out. So we have triangle ABC here that we are trying to prove something about. So let me redraw that one. Triangle ABC. And we also have triangle EBD. EBD. So let me redraw that one. And these drawings are not to scale. They're actually not very good at all, but it's helping me visualize it. So now we can go mark the given information. So angle A is congruent to angle E. First, I'll mark that here. But also, I want to mark that over here. Angle A is congruent to angle E. Then AB is congruent to BE. So AB, this whole segment, is congruent to BE. This whole segment. So I'll mark that that way. It's easier to see over here. AB and BE are congruent. Now, whenever you have overlapping triangles, you want to think about, okay, what part do they share? And a lot of times they share a side, and we've seen that in many cases. But this time they don't share a side, they actually share an angle. Check that out, they share angle B. So by the reflexive property, I can go ahead and add that in. Now, it should be apparent to you now that the triangles are congruent by angle, side, angle, so that's the direction that our proof's going to go. It's just a matter of stating everything that we just marked very clearly. Um, so I'm going to use a paragraph proof again just to save space. If you want to rock the two column, that's great. Each sentence will correspond to a row in your two column proof. So we know from the given that angle A is congruent to angle E and AB is congruent to BE. So then we said angle B is congruent to itself, angle B, by the reflexive property. Thus, triangle ABC is congruent to triangle EBD by angle side angle, the angle side angle congruence postulate. And that's it. So it's a three-sentence proof. So if you did about a two-column method, it would be 3 rows. Given, reflexive property, angle side angle. Booyah.